Okay, so we've seen a little bit about classes now, and we know that they have private aspects and public aspects. And the public aspect is sort of an interface, a way that you can view the class from the outside. And the private aspect is the implementation of the class. And part of the theme of this course is the power of being able to hide an implementation and what that allows us to do as developers. Specifically, what it allows us to do is change the implementation at will as requirements change or techniques change or resources change without having to change the interface to the class. So let's take an example of a point. So let's draw a point in space like so. And we want to locate that point in space. So we say, all right, well, we'll draw a x and y plane, and we'll locate the point in space that way. So it's got some value on the x-axis, and it has some value on the y-axis. And so, I don't know, let's say that that's point 3, comma 2. So that would be using xy coordinates or the Cartesian plane to locate that point in space. But another possibility is using polar coordinates, and that is a line drawn from the origin, and that's usually referred to as r for radius. These are polar coordinates. And then the angle of that line, which is often referred to as theta. All right, so I could represent that as an r theta value or as an xy value. So what would that look like in code? There's one possibility. So we've got this idea of a coordinate, and it has a constructor, as you can see here, that does take the Cartesian coordinates x and y, and it also has a constructor that takes, instead of x and y, radius and theta. And of course it does some trigonometry here, so you can convert back and forth between the two. And it really doesn't make any difference what that calculation is. The point is that it can be done. And in that way, you can return to the user using a property the value of x and y, or the value of x as a property and the value of y as a property. And because that's the way it's actually implemented, that's a pretty simple set. It just returns x or sets x to value, just returns y or sets y to value. All right, but it also has a property for radius and a property for theta. And as you can see, we just use some trigonometric identities to determine what x should be and what y should be in a pretty straightforward way. Okay. The important point about this is that it only has one implementation. So the single implementation here, this is the implementation, is as Cartesian coordinates. But the thing is, the user, which is to say the code that's making use of this class, doesn't need to know that, doesn't have to know that, in fact, shouldn't know that. And so in that way, when you actually make use of this class, you can create a Cartesian point at this point, for this particular example, it's at the point 3, 4. And we can also create a polar point. Now, in this case, I went ahead and converted the Cartesian point into r theta so that you could see that you could go back and forth, but also recognize that it's not as if they have to be connected. So you can create a third point here. It's at C3, and you could say that that's a new coordinate and give it a radius, and any double value will be fine. So let's say 10, and a theta of, let's say, 35. And you would expect that to be measured in either radians or degrees, but it doesn't really matter. The point is, this is a polar point. And the fact that it's represented or implemented in the coordinate class as a Cartesian point is immaterial. I'm able, as the user, to use the object any way that I like, which is kind of the point here. What we're doing is we're allowing the user more freedom, at this, because they can specify things as polar coordinates or Cartesian coordinates. And at the same time, we're allowing the developer or the person that wrote that class more freedom, because they don't have to worry about whether or not they choose to represent the point as polar coordinates or Cartesian coordinates. It's going to work either way. All right. So probably the last important point here is recognize that you do not want to have more than one implementation. So in other words, you can represent your point as Cartesian coordinates, or I could change this and represent it as r theta, polar coordinates. But what I definitely don't want to do is to have both in one class. So as the title of the section indicates, alternate interfaces, one implementation.